It's already over that now. Okay? And I did have actually marked the latitude lines on the bottom, but we erased them when we did the other experiment yesterday. Okay, you can imagine equator, 10, 20, 30 degrees. Okay? Now, it takes a few minutes for the thermal current. In the absence of rotation, what do you expect to happen when you have this thing of cold water? Well, we saw that in a two-dimensional non-rotating frame of reference, right? Here's cold water, here's warm water. What happens? We just did the experiment over there. That experiment would be the equivalent of that little thing I just showed you, a slice across here, right? Cold side, warm side. Cold side, warm side. And I opened the valves, and what happened? Cold side pushed the water over, warm side came up and replaced it. Right? So what's going to happen here is it opens this. What's happening is presumably at the bottom of the can around the green dotted line, water's starting to drop, and it's heading radially outward. And then it can't go any further, so it rises, this warmer water out here rises and drops to replace it. So we're seeing circulation like this, right? So what we hypothesize is that water is rotating. Imagine this thing is actually donut shaped. But that's an idealized Hadley cell there without rotation, meaning without the rotation of the Earth. And so which way is the water going to be going at the top? It's going to be heading towards inward, poleward, and equatorward at the bottom. So it's heading towards the equator at the bottom and towards the pole at the top. Okay? Now, how are we going to visualize that? Well, one convenient way to do this is a little container of potassium permanganate. For your notes, that's KMnO4. Potassium, manganese, and 4 oxygens. Okay? Potassium permanganate. Now, it's an interesting chemical of its own right. It's used it's a fairly powerful oxidant. It's used in water treatment and some other things. You get to understand it and burn it. Let's not do that. But the only reason we're going to use it at all has nothing to do with the interesting chemical properties. But since these are like basically salt crystals, when I dump them in, where are they going to go? Right to the bottom. But they're also brilliant. They release a brilliant pinkish purple color, which is really cool looking. And so the crystals are going to sit on the bottom, and then they're going to slowly dissolve and release a bright pink color. So we're going to be able to basically dye the water at the very bottom of the tank, okay, and then see where it goes. So what I'm going to do is put a few crystals as close as I can. Here. Cool, huh? The little streamers that leave behind are fun to watch, but they're kind of irrelevant. What we mainly want to focus on is ignore those little random swirls. They're not telling us anything. What we really want to focus on is as the dye dissolves, it's going to form a fairly thick pink tongue-like projection. If there were no rotation, what would happen? Where would the pink tongues? Where would you hypothesize the pink tongues go? Straight out towards the wall, right? Because the water is heading. We said water's doing this. So we should see a nice, in say 5 minutes, what we should see is like spokes, right? Well, let's look both at the tank and in the camera. And it's traveling outward all right, isn't it? So yes, it is traveling outward. Verified. Is it going straight out? Okay. So this is where you should take turns getting up close to it. And do not stick your head when this thing is going around. You can go like this to take your head out. But everybody should actually look down in just to get a good look at it, and then take a pretty close look at the camera. So everybody take a turn. And it's not too informative right now. You can look sideways at it. We will be looking sideways. Everybody get a close look at the board. And feel free to take pictures and stuff.
Picture that. It's really pretty. Look at the colors.
Oh, and all right, and of course, it's not only is it not going straight out, but which way is it curving? To the left or to the right?
To the right.
That as it should be for the northern hemisphere. Yeah, we said we're replicating the northern hemisphere.